Hello everyone, today we're going to be going over the 2026 FECOS MA exam, problem 15. Now, first I want to start out with the joke of the day, and that's going to be, why did the bicycle fall down? It was too tired. Okay. So now let's read the problem. It says that a ball launcher fires balls along the floor at some initial speed, applying no rotation to them. The balls initially slip along the floor, then start rolling without slipping. Ignore the potential deformation of the ball and flooring during this process, as well as air resistance. How does the final speed of the rolling ball depend on the coefficient of friction mu between the ball and the floor? So the answer choices, one of them says that the final speed is larger when mu is large. It's the same regardless. It's larger when mu is small. And these two talk about special cases for high and low launch speeds. Okay. So first, I'm going to draw a diagram of this. So we have this launcher, and it shoots balls, right? So we have, I'm just going to draw one ball here. And so here, this is the launcher. And so initially, let me duplicate this. Yeah, so I'm going to draw two. The first one is when it's rolling with slipping, right? No, well, let's just say that once it's shot out. So this is immediately after it's shot out. So it has over here, I'm going to call this V naught, okay? And finally, we have this VF, right? And VF is going to be less than V naught because some of the energy is converted to rotational energy. So this is omega, okay? And let's draw the forces on here with this green color. So we have normal force. And, let me use a different color. So we have, I'll just draw it from the point of contact. So normal force, gravitational force, and we have friction. And friction is going to be working this way, right? So that it spins. And now, are there any other forces? Well, no. So it's just these three forces, right? And now we can think of something clever to do. So if you notice that all three of these forces have zero lever arm away from the contact point, so they don't cause any force here, right? They don't cause any torque here, like about the contact point. So about contact point. And since there's no torque about contact point, so that means that since the net torque is zero, that means that angular momentum is conserved, right? So L is conserved. So now we can write conservation of angular momentum. L initial is equal to L final. So the initial is going to be this. Now it's just M times V naught times, just call this R, equals the final angular momentum, which is MVF R plus I omega. And so basically, let's see what the question is asking. It's about mu, right? And since mu doesn't exist in equation, okay, then And we can rearrange this to solve for V naught and VF and stuff like that. But we know that since mu doesn't even exist in the equation, it can't possibly like affect VF in terms of V naught, because we know that I is going to be defined, and since omega is going to be equal to V over R, since at the end it's rolling without slipping, we know that none of these terms depend on mu, and our answer is going to be answer choice B. The final speed is the same regardless of mu. Yeah. So thank you for watching. If you have any questions, please leave them in the comment section, and make sure to like and subscribe. Thank you.